This is Solve It for Kids.
Hello, my amazing and curious friends. My name is Jennifer, the Dean of all things STEM and STEAM, and this is Solve It for Kids, the podcast that gives kids and families a peek inside the real world of scientists, engineers, and experts as they solve problems in their jobs using creativity, cooperation, and critical thinking. And now please welcome to the show my podcast partner, Galactic Space Geek, Jeff Gagne.
Hello, Jennifer, and hello, listeners. Well, any space fan, whether a space geek or not, has to love rockets because that's how we get there, and we have the guest to talk to today.
We absolutely do. What problem are we solving today?
How do you get a rocket ready to launch?
How do you get a rocket ready for launch?
Yes.
Ooh, I think this is a topic we haven't yet covered, but we are going to learn so much about. Who is our guest today, Jeff?
Our guest today is the wonderful Nathalie Quintero, and she currently works for Boeing on their SLS program as the core stage launch operations lead.
Welcome to the show, Nathalie.
Thanks, guys. I appreciate it. I'm super excited to be here with you today.
Well, we are super excited to have you here. This is going to be such a fun discussion. But I like to ask for our young listeners out there, did you always know that you wanted to work with rockets even when you were a kid?
Actually, no.
Okay.
We get that a lot, actually. So what did you want to do?
So when I was a little kid, I first wanted to be a pilot, actually. I had the opportunity that my dad was a pilot himself. So I had that role model in my life early in my,
Right.
And I remember asking for Christmas one day, the Barbie pilot.
Okay.
I remember her.
Back then in the late 90s. And now with the Barbie movie coming up, which is pretty cool. But yeah, I remember having that and wishing to be a pilot, and flying was one of the first things that I thought I was going to do. But later in high school, and I did my high school in Venezuela, actually. I came to the U.S. to go to college.
Okay.
Had, maybe what did I like? I really like science, like chemistry, physics, math classes.
Right.
I really took one design class and a drafting that kind of opened my eyes to what engineering could be.
Wow.
So I started looking into, okay, maybe engineering could be an option. My mom is an industrial engineer, but she stopped working when I was born. So I never really saw her in the engineer role, the mother role. She worked 10 years in the industry before she had me. So I really never saw an engineer really close to me or my surroundings to say, okay, yeah, this is what an engineer does. So is there something that combines aviation with engineering? And I ended up discovering something called aerospace engineering. So I started researching about that, and in Venezuela, they don't have that major in any of the universities that are there. So I started looking outside, maybe Europe or the US, and I stumbled upon Embry-Riddle Aeronautical University.
Okay.
Yes.
Very known for aviation in general, but also for engineering. And I was like, okay, I paid a visit to the campus one before, it was my senior year. And I was like, okay, this is where I want to go. And I went to the Daytona Beach campus. They have two campuses, one in Prescott, Arizona, and one here in Daytona Beach, Florida. And I loved it. I loved the campus, the people, the fact that everybody was so aviation, space oriented.
Right.
I did start at college when the shuttle program ended, so I never got to see a shuttle.
I
did in my life, really.
Yeah.
But going to campus and just being surrounded about that, it really opened my eyes into not just aviation, which is what I was familiar with, airplanes, from having an airport, by the international airport in Caracas, but seeing a space. And I remember seeing one of the first rocket launches was a night launch. It was when SpaceX was doing their Dragon demo.
Oh, wow.
Okay.
And then I saw ULA launch, and I was like, wow, interesting. And then I would always go to Kennedy Space Center, to visit and to geek about it.
Yeah.
And life led me to Kennedy Space Center actually to do, real work with plus program. So that's kind of like how I ended up working on rockets. But yeah, like life has its mysteries to work around it. So
wow. I love how you
fun.
just put that life has its mysteries in figuring that out. One thing you mentioned that I have never heard before, I've heard lots of folks say, and especially on the podcast, that they come to engineering not in a direct route. Something else kind of happens. I have never heard anybody sort of come to it through a drafting class. Mm-hmm. Was there something that happened in that drafting class? Was there a project you were working on that you were designing something that sort of led you towards engineering?
Yeah. So in the drafting class, we had to do kind of like schematics of like, well, it was houses. The class had, and I was like, it was more like architecture if you think about it a little bit.
All right.
But I was like, oh, that's cool, kind of designing in this case, the layout of what a house could be, and then what is like, the materials that it needs to be. And I was like, okay, you can play a role into design, even though I don't do design engineering as my current role, I do operations. But I think in general, though, even in whatever phase you might be in an engineering project, having that creativity, I think it pains out, through other disciplines within the engineering world. And engineering is really big. You go into studying aerospace engineering, you can be doing millions of things.
Yep.
Yes.
My classmates, we all did the same classes and we all do different things. Like,
right.
Keep in touch. So I think, and that's one of the values of like doing internships too for students when they get to that point. And I actually have learned that some high school students even have internships now, like NASA has that opportunity.
Wow.
Companies do that as well. And that's awesome because that is really how you engage and see, oh, look what I can do. Or maybe I didn't know that, because you can touch everything in a classroom.
Right.
You're doing a degree. It's impossible. So, yeah.
Okay.
That's amazing. My son is a material science engineer, but there's so many different ways that he can take that. Same thing as you were saying. So now you work for Boeing, which is really cool. And you get to work on the SLS. So tell us a little bit about what you do now.
Right. So I've been working with the SLS program over now 8 years now, which is kind of crazy to think about because I started with Boeing as an intern in their Boeing Commercial Airplanes division up in Everett, Washington.
Wow.
And I made my transition into space on the last summer before graduating college. One of the reasons I wanted to work is obviously, space looks cool. I did actually a project with Johnson Space Center as a student on the Vomit Comet.
Oh, wow.
Okay. Yeah. They had a whole program for like college students called the Reduced Microgravity Flight Program. And basically universities across the country would compete to get their experiments to fly on board the Vomit Comet. I did that in 2014 with a joint team between Duke University and Embry-Riddle.
Wow.
And I think that was the first time where I was like, wow, this feels like I'm an astronaut and it was so cool to work in space. Because when we went on the flight and the airplane did parabolas and you're literally floating for like a couple seconds, obviously, but it just feels surreal because you feel like you're in a pool, but there's no water sustaining you up in the air. Your body's trying to figure out what is happening. And I remember the first parabola, all the students were so excited about, just the feeling. And then it was like, okay, everybody get to your experiments. We do.
You can't just fly around. So I do have to ask,
joy, right?
Did you throw up on this and get sick, or were you one of those lucky people? Oh my gosh.
All right.
So
good for you.
Guys.
Yeah, they did 4 flights, and my flight with the people we were did not vomit, but the other ones, at least 1 or 2 people did. Yeah,
I can imagine. Yeah,
well, but it does get the name, right? The Vomit Comet.
Exactly. But what a really unique experience that had to be.
Yes, and that actually was the one that I was like, wow, like it would be really cool to work in space. And so as I was interning, I did 2 internships in Boeing Commercial Airplanes. And I was looking to see, well, what other opportunities are there for space? Well, Boeing has a big portfolio in space, not just rocket, but we do satellites. We have Starliner, other projects. Right. We are involved. And at the time, I was looking to go to California because that's where our satellite development center is at. But there was no opportunities at the time. So life led me to SLS, really. Opportunities through networking, really. And also, I didn't want to live in the north because I'm from South America. So it would have been really nice to stay in the lower part of the country. And so, I got the opportunity to go work in the SLS program on my last internship before graduating college in Florida at the Kennedy Space Center. And I've been there ever since.
Wow.
My career has been working on Artemis 1, which we launched last year.
Yes. Yay!
Yeah. And now I'm working on Artemis 2, which is going to be the first, manned mission. And I'm super excited about that. I know Jennifer and I got the opportunity to see the crew, and that was an amazing thing.
Oh my gosh, that was phenomenal. Phenomenal. Yeah.
You can actually put, you're working on day-to-day things, and like any job, you get great times, challenges, but it's really important to keep the goal in mind, which at the end of the day, it's like we're doing this rocket, to advance humanity, but also we have the crew that we need to take care of. Like all parts in the rocket are very important to operate correctly so that crew is kept safe. So I think that to me was really special because it's a great reminder of what to have in the peer view always as whatever you're doing in whatever stage you're working on in the vehicle. So.
Exactly.
So when I got to introduce you at the beginning of the show, your title right now is the Core Stage Launch Operations Lead. And I think that leads us right to our main question for this episode of how do you get a rocket ready for launch? Can you kind of talk to us a little bit more about what that directly means?
Yeah, absolutely. So yes. So launch operations is really like the final stage of rocket development, is the last phase that you're getting ready that rocket to, go up to space. But before you're getting to the countdown and you're out of the pad, there's various tests that the teams have to do. In our case, for the first mission, the core stage, because it was a new piece, new design, we had to certify it via green run hot fire test, which we did a couple of years ago. I think it was, 2021 is when we finally did the successful hot fire. So that was basically, you strap down the rocket in this test stand and at Stennis Space Center, and fire the engines for the amount of minutes that it's going to be in the air, which crazy to think it's only 8 minutes in the air.
Yes.
From liftoff at, on the platforms here at Kennedy Space Center to going now to outer space, it just takes 8 minutes and is a massive structure. We tested to verify that the avionics on board, so all the flight computers and electronics on board are working properly.
Right.
The propulsion system, which is mainly what our core stage is, has 2 tanks, the LOX liquid oxygen tank and then the liquid hydrogen tank. Both of these chemicals are needed for the combustion of the engines that we have on board. And we obviously fire them to see if this whole structure can withstand the vibrations that you'll probably endure during flight.
Right.
That the avionics are supposed to operate as they should. That if there's any errors, that they detect them properly, and the computers have, different contingency procedures to do.
Wow.
And all that we did successfully to basically certify that the core stage is good to fly on Artemis mission. So that we only do one time to certify the stage, really, like the design.
Okay. Yeah.
But once that is completed, the whole stage got sent over to Kennedy Space Center. And really here at Kennedy is where we put the rocket together. And when I tell kids, it's like, it's kind of putting like a Lego together. It comes to life in this big building called the Vehicle Assembly Building, or the VAB, a historic building where the Apollo rockets, Saturn V, were built, the shuttle was put together, and now the Artemis SLS rocket is put together. So here is where, like the boosters that go next to our core stage, the core stage gets, stacked. And on top of that, we have other components called the ICPS, intercryogenic propulsion stage. And we have on top of the capsule and the launch system. So all of these are pieces that get together. And once we have a full integrated rocket, we have to do a series of what we call integrated test and checkout operations test, or ITCO is for the short term of that. It's basically a series of tests, different capacities, different systems are tested. RF, radio frequency, we're testing the electrical components, pneumatics, the propulsion system, because you have to make sure everything, at the end of the day, everything works like an orchestra all together. So after we do a lot of those tests in the VAB, we do that in the Vehicle Assembly Building. right before heading to the pad. Once everything checks out,
right.
Team, we did testing at the pad because obviously it was the first Artemis mission. We needed to test also and check out the systems out at the pad. We were also testing the light poles, for all the thunderstorm activity that we get here in Florida.
Yes.
Rocket doesn't get hit. So yeah, rolling out the rocket from the vehicle assembly building to the pad is a 4-mile journey, but it goes like half a mile per hour because it's very heavy structure. We also reuse the crawlers that have been repurposed, I think, since the Apollo days.
Right.
So definitely, obviously, older infrastructure, but very obviously, from an engineering standpoint, is a very interesting engineering marvel because it's
absolutely. Yes.
Each rocket, and you see, that's just like moving along the road. It's pretty impressive. And yeah, at the pad, we also do other testing to make sure now, because we don't have the interference of a building, to make sure, like, for example, the satellites with the rocket are communicating.
Okay.
Yeah.
Also, Orion capsule, the inner cryogenic propulsion stage, all of them have certain antennas that they have to be in communication with TDRS. That's a satellite that's in space that is basically for deep space, like waves and data telemetry, to make sure that we're receiving and the satellite is capturing the data. And that's very important because obviously when you're in space, you get delays in certain information and data.
Yes.
And you want to make sure that you're communicating right and you have the right status. So we do those checkouts there with the satellite, as well as other propulsion really tests that we do to make sure, okay, are the valves on inside the rocket working? How does that connect to we got 2 spheres out at the pad, which loads the rocket eventually during a launch day. So you want to make sure that all of those subsystems are working ahead of, okay, now you're rolling out for launch. This is the big day. We have time window because that's how orbital mechanics work. You don't have all the time of the world to launch rocket. You also have to fight weather. Being in Florida and having a couple months of hurricane season is also, we did see that last year.
We did, yes.
We had 2 hurricanes come through during that period of launch attempts. So definitely you're fighting not only the vehicle response, but also external factors like environment plays a big role into it. And then also mission availability, making sure that the folks that support, from not only the console perspective, but we also have the Air Force supporting from a range perspective,
right,
as well as, just like Mission Control 2 up in Houston, because they take over, like after we launch, they take over the mission. So
right.
It's a whole big team really that puts all this together to launch the rocket. But so yeah.
It's so much.
It's so much. And I'm just thinking, 2 things. One, the list of things that you have to check off must be like, the longest list ever. And then can you give us kind of an idea of a timeline? Because you had to build the core stage, right? And then you test it and then you launch. Like, how long did that take? And is there like thousands or tens of thousands of steps kind of along the way to that?
Yeah, absolutely. So being a developmental program, obviously, if you haven't done it before, if it's a new design, it takes time. I think it took over a decade from like the concept to launch the first mission. I know I personally worked 7 years of that decade in launch operations. I also supported different in the manufacturing perspective. We have our manufacturing facility in New Orleans, Louisiana. And I did support green a little bit because I was interested in actually learning about how do you test rockets? Because I've never done that.
Right.
That always piqued my interest. And I knew it was also going to prepare me and help me for when we got the core stage here in Florida to be ready for a lot of those things. So yeah, it does take years to get a mission out. Obviously, we want it to be very successful. That is really the foundation for future Artemis missions. So yeah, it does take a while, a lot of steps. Testing and certification is very important. You want to do things with quality. So obviously keeping those in mind, it takes time.
Right.
Oh, wow. Yeah.
So having launched Artemis 1 now and being able to work towards Artemis 2, how well did Artemis 1 go in terms of that core stage that you work on so that you can move forward?
I think the core stage did really great, like in flight.
Yay!
Super.
I mean, it's separated on time as it should. I think you've seen it in simulations and things are supposed to break off and separate.
Right.
But you hear it from the rocket you've been working. To me, I remember on launch day, they confirmed separation. First was the booster separate, like about 2.5 minutes.
Okay, yep.
And then its core stage separates, which for me was like, okay, I cannot breathe until we've separated. And then the journey continues, right? The mission's not done yet.
Right.
ICPS with Orion on top, going around Earth, putting Orion in the right trajectory to go to the moon.
Yes.
And then they separate, and then it's like, okay, Orion, you're on your own, go to deep space. So yeah, I think in terms of our core stage performance, we did pretty good for being the first mission. I think as in any program, you want to optimize processes, you want to optimize designs, maybe, what about, this design could be better. And that's, I think, what engineering really is about when you're now going from a developmental program into more of a, production program, and you're to do more missions now. I mean, there's a whole Artemis agenda about what each mission is supposed to do. So I think, there's always improvements that we can do, but in general, for the first mission, very successful from beginning to an end. So I would say very, very excited for what the future.
That's terrific.
That's fantastic. So now you're working on Artemis 2 core stage, and that is hopefully planned to launch in 2024, 2025, right? Something like that.
Mm-hmm.
So have you tested the core stage yet for that? Where are you in that kind of?
Yeah, so we're finishing production of that stage up in New Orleans and Michoud Assembly Facility. That's where we put the rocket together. And eventually, towards the end of this year, we'll be getting that core stage here at Kennedy Space Center and then start kind of like processing again as how we did for Artemis 1. I think that processing probably be about a year, before we can say, okay, the rocket's ready to go launch. But so I think, yes, even though you feel like a year or a year and a half might be a little long, I think it's going to come, sooner than later. I mean, we're already in July.
Yes.
Year, which is super crazy. I just feel like I just launched last month. It's like 8 months. And
then it's like, do it again. Come on, let's go.
Yeah, I think everybody looks forward to obviously the next launch. I think that was really great.
Yes.
Team building and team morale, and like everybody really having that like, wow, this is the next program. This is like the next big thing for the agency, but also for all the contractor companies that support that. And, all the scientists that are interested in riding along Artemis, I don't know, maybe conduct science experiments.
Absolutely. Yeah.
So I think I can't wait for the next mission also, because it's going to be, with astronauts and just probably like hearing them live, like transmit from like, hey, we're seeing the moon.
Yes. From a lot closer than you are.
Yeah, exactly.
So that actually kind of leads me with the astronauts going around the moon for Artemis 2.
Yes.
That kind of leads me into a question. You mentioned that you said it feels kind of surreal that you've already been with Boeing for 8 years now and you've been part of this program. Do you imagine yourself sticking with the Artemis and the SLS program with Boeing, at least through the launch of Artemis 2 and maybe all the way to Artemis 3 for the next landing?
I definitely see myself like continuing to be part of the Artemis program. Definitely super excited about Artemis 2 because there's a lot of firsts in the crew.
Oh, yes.
Yes.
And it's just like super excited to just be a contributor to making that happen. I think I would feel like, but from a personal perspective, like super accomplished that, I put my grain of salt to make it happen. Obviously, it takes a village really to put all the 4 astronauts in space.
Sure.
But, even if you have this little portion in the project, do it right, because it's a domino effect that everybody really has a great role and very important role to play in it. So I definitely see myself in the next mission. And I would definitely love to see the landing. Obviously, I hear my parents were young when the, Apollo 11 astronauts land.
Right.
TVs were black and white. So
yes,
that landing in color and maybe high definition would be amazing. My memories and, for the future of the kids' memories too.
Well, and it's so exciting too, because I think you and I, since we got to do the NASA social event at Johnson Space Center, we got to sit in Orion, which, by the way, you know, hats off to all of those astronauts, because those are very tight quarters. Right. But then we got to kind of see all of that. And then I'm assuming you saw the launch of Artemis 1. Yes.
Yeah. I was actually working that night.
I was going to say, so we haven't asked you, like, what was that like to be there and watch the rocket you've worked on for 7 years go up?
Yeah, no, it was definitely an amazing and surreal emotional moment. Definitely, I was working all those launch attempts. I was working the day that we launched that night, really, because
it was 1:30 in the morning. Yeah, something like that.
Yeah. I think it was really special that the first mission was a night launch. I know our first two attempts were going to be actually day launches, but the fact that it was a night launch was even more magical because you could see the rocket, you know, light up.
Yeah.
It's like, to me, it reminded me of the Lion King when like the sun goes up.
Yeah, it was like daytime, wasn't it?
Yeah,
in the middle of the night.
It looked like daytime. And then you're seeing the rocket go. It was also a full moon day that day.
Yes.
So it was really cool to see, like you would see the little dot in the sky and next to it, and you're like, wow, this is where Artemis is going, and this is surreal because you can see it. It also was like emotional because you've put a lot of, you know, sweat, tears, time dedicated. Everybody has made personal sacrifices, like, you know, missed holidays or, you know, important things for your own life in pro of the program. So seeing it come to life finally after, you know, many challenges that we've had, and definitely last year, you know, not only fighting the hurricanes, fighting challenges that we've been testing, I think that was like, wow, we finally did it, and it finally lifted off. And
it was amazing.
I've seen other rocket launches out of Kennedy because I have the privilege of living in a state where we launch frequently, and it doesn't get old. And I've seen the rocket you've worked on personally. It had a different significance for me.
Oh, sure.
And I was just really proud of it finally coming to life and actually being very successful. So
as you should be.
So right now, I am, as Galactic Space Geek Jeff, super excited about the Artemis missions and talk a lot about the crew that you guys got to meet at the NASA Social. Moving forward, I notice a lot that, you know, in general, the general public isn't quite as jazzed up about Artemis right now as Apollo back in the 60s. That was the first time it was done. And there's a little bit of, okay, we've done these, you know, big rocket launches before. From inside the team, do you see that the next launch, the Artemis 2, as soon as we add humans, as soon as we add astronauts and the super cool people that they are, do you guys envision that the general public all around the world is just going to jump right back in, and we are going to have moon fever and space fever, and let's keep moving these programs along, and let's get this landing to happen?
I definitely think we'll get more visibility because people are going to be on board.
Yes.
I know when we did the first launch attempt in August of last year, it was crazy. Like Titusville.
It was insane.
I think, even the people, the guests that were on, you know, they had guest passes, also people that bought passes through the Kennedy Space Center Visitor Center. It was collapsed. Like, I remember my parents came to see it, and they're like, at the entrance, the gate, you had to be there like hours early to get in. Very, very, you know, very collapsed, really. Obviously, with the attempts, because I didn't go, people were like, oh, you know, maybe it's not going to go. Some people say, well, especially on that night launch that we actually did launch.
Right. That was
went to bed because they're like, oh, probably it's not going to happen, maybe. But I think, you know, and I try to do this through my outreaches, you know, try to get students excited so that they can see it's like, you know, you're seeing history in the making.
Yes.
Yes.
I think with the fact that there's going to be a crew on board for next mission, and if, you know, it's a 10-day mission for them in Artemis 2, and if they get the opportunity to transmit live from space, like fly by and by the moon,
exactly,
that'll have a ripple effect on, like, you know, not only the United States but the world, really, because this is like a world event.
Right.
Remember, you know, when we had that first launch, like the whole press from different countries were there, as well as like representatives and elected officials from different countries too. So it's really like not just like, the US, but it's really like a humanity effort. So I think the next mission will spark that inspiration that when we go to Artemis 3, and that will be the landing mission, which also is a first for
yes.
I think would be really excited. And if they can, I don't know, I can just imagine if you're landing and you're like, wow, I'm here. Like, that's how the TV show, no, just kidding. Give that personal perspective. I think that connects the public and the kids and inspiration to think or aspire to be that one day, or to be the scientist that contributes to the missions, or
exactly
the communicators. Like, you need a whole team, really. Engineers and scientists is just part of it, but it really takes a whole team to make it happen, to also represent and communicate all of what is happening really to the public. So
yeah,
right.
That's very well said. I agree too. I think the human element will get everybody more on board with it and be excited about it. But I mean, we already are. So, I mean, they should just, follow what we're doing. But anyway, we have reached that part in our show where we ask all of our guests to give our listeners a challenge. So what challenge do you have for our listeners, Nathalie?
So for our listeners, I have the challenge. There is a NASA resource for Artemis to do for summer activities where you can do your little rocket and stabilizing fins.
Ooh,
so I challenge the kids to go build their own little model rocket out of cardboard and test the fins. So the fins provide a lot of the stability and control for rocket flight.
Right.
So just to, test out, see maybe the design is bigger fins, smaller fins, position them, play with those, and see how your rocket behaves in launch.
Oh, that'll be fun. Everyone do that. We will absolutely have this link on our website, Solve It for Kids. This has been so much fun. I have learned so much about preparing a rocket for launch, Nathalie. So thank you so much for being on Solve It for Kids.
Thank you, Nathalie.
Thank you guys so much.
I tell you, some of our guests, and actually all of our guests, are fascinating with the passion they have for their job. But talking to people that have similar passions as you, because not everybody's going to like everything, but learning from somebody this close to how you launch rockets and get them ready for launch, the details that these folks are sharing with us and that Nathalie shared with us today, they make these episodes so much fun to do, Jen.
They really do. And I love that, for me, the coolest thing would be seeing the stacked SLS in the VAB, right? I mean, wow.
Totally.
Wouldn't that be amazing? And to be there doing that and then being the one that's testing it, I mean, this is an amazing job. And
absolutely.
It was so great that she could share all of this with us, wasn't it?
Oh, absolutely. And the amount of detail that they have to take for a rocket that's the size of a skyscraper. And then for her as an amazing guest to bring it right back down to something a lot of our listeners, I'm sure, have done, which is making a rocket challenge. Building your own little rocket out of whatever kind of paper you're using, whether it's thin stuff or thicker stuff. But to actually focus on the fins and the details and then launch multiple times so that just like a scientist or an engineer, or just like Miss Nathalie and her team, you collect the data over those different attempts and then you figure out which one is going to work best.
Yeah, that sounds so much fun. We might have to do that. Hopefully this will inspire many kids to go out and play with rockets. And by the way, when I say kids, I mean kids of all ages.
All ages.
All ages. So if you do this, share your information with us. We'd love to see pictures of your rocket or something. We are at Kids Solve at Facebook, Instagram, and Twitter. You can tag us there. And of course, for every episode, just like this one, we'll have a page on our website, solveitforkids.com. And there we'll have the information that Nathalie was referring to about NASA's STEM project, where you create this rocket. So make sure you go and look that up because we want to see what you create.
That's exactly right. We want to know and we want some data. And heaven forbid you share a picture or a video with us of yourself launching a rocket. But don't forget to come back inside because Jen and Jeff will be creating more episodes of Solve It for Kids.